So now in this video we're going to do a better demonstration of topics I covered in the last video, most of the topics. So in any case, we got a 9-volt power supply there. It's off though, so everything is off until I turn it on. So now we turn that on, and we are charging the power bank right there. So you can see the amount of current flowing. And an interesting thing, we need to power this and power that. So it looks like about 20 milliamps of current was being used just to power those. So that was a problem I had in the last video. Some of the current we saw on the display here was that unit. We weren't using this unit. Now this is basically a multimeter there. So it's got USB coming in and USB out. That's a USB data. Somebody pointed out that if they're gonna charge something, their phone or something, with the computer, they use this port there because then it won't share data, whereas that one could share data. So in any case, we got 9 volts at display. So 5 volts is going to this power bank. And so the most important thing is this is a buck converter. So we got the battery clamps there. The clips are from the power supply. The clamps are to power this. And it takes a higher voltage up to 35 volts. This only goes up to 30 and outputs 5 volts. Now there's a benefit to that when you have a buck converter. Linear regulator just kind of adds resistance, there's waste heat, but buck converter actually takes some of that extra voltage, 9 volts there, and produces more current. So you can see we have less current from the power supply right there. And you notice if I go down to 8 volts, actually sometimes that shuts off at 8 volts. There we go, 7. 7 says 8 on there. Before it wasn't turned on. Okay, so yeah, it looks like we could use 8 volts minimum. Now, so we go to 10 volts. We got twice the voltage that we're outputting, and you can see that it's, you know, relatively close to half of the current that it has to provide. So there's not 100% efficiency. If there was, then we would have, if this needed 2 amps, 1 amp there. So this would be a little lower. But in any case, we can go up to 15 volts, and that was the maximum current. This is, I believe, a 40-watt unit right there. That's all it can provide. So as we raise the voltage, it's going to lower how much current it can provide, and it fixes that setting right there, as you can see there, but it has to lower it. But in any case, we got 15 volts there, and again, current's holding steady there, but it's going down because as we use more voltage, again, this is converting that extra voltage into more current right there. It's outputting 5 volts. That 15 extra volts. There you can see that you know, we got like 4 times the voltage, and it looks like, you know, about 3 times as much current out as we are putting in. It's converting it. So we're saving energy versus using a linear regulator where all of this extra voltage would just be waste heat. It would be getting very hot, and you need big heat sinks and everything. Converting the voltage is much better. So in any case, that's about all there is to it. I think I showed this pretty well. We have the Alligator clips from the power supply to the clamps, and they come over to this unit. We looked at this in the last video. I'll zoom in. But you can see that these can output the USB on the end right there. They can output, looks like 2 amps each. And so there's 5 of them that output 5 volts for USB, and but it's an 8-watt unit or 40-watt unit right there. So 5 volts times 2 amps each, it would be 10 watts. So 10, 20, 30, 40 watts. I'm pretty sure that is accurate. So yeah, it's a USB out, and this is a Drock USB tester right there. I think the newer ones are more likely to have USB-C. I could be wrong, but in any case, this is kind of old. But they should work the same. So it automatically shows you the voltage, the current. You can also change settings, capacity. So this is letting you know how much current has flown through for a period of time. And so if it's at 1, then that means we might have had 1 amp going through for 1 hour. That's what it means. So it's adding the current plus the time, and you're getting the amp hours. Actually, it just yeah, measure current. It doesn't measure wattage. So it's giving you the amp hour. And so we got the USB out. It's a really long cord. right there, so I'm not going to show the whole cord, but that's going into the charging port. And this seems to be the best output. I use this to recharge my phone right there, and so I'm going to leave this plug in there. I got to make sure I put it in that one. Phone doesn't seem to like to charge with the other ones for some reason. But in any case, you saw higher voltage in with the lower voltage out. You get more current out than you had to put in. It conserves energy, and not completely, not perfectly, but pretty well. So in any case, if you found that stuff confusing in my last video, hopefully that cleared things up. And I'm going to set this to 5 volts. This will cut out. Usually I use 5 volts with this, so I try to always set it to 5 volts so I can kind of assume when I power it on that it's 5 volts. I don't want to fry something that needs a lower voltage because I had this set too high. I'd rather the voltage be too low and the stuff just not turn on, and I have to figure out why. So thanks for watching. Check out the links down below. They all help a lot. I'll see you on the next one.